In the study of electrostatics, we've looked at four main quantities: force, electric field, potential energy, and electric potential. Let's quickly review each of these. We started with forces, and this was the observation that opposite charges attract, like charges repel, because there is an electric force acting between them. And that force for point charges was given by Coulomb's law. The next question was, why are these charges attracting or repelling in the first place? And to answer that question, we developed the notion of the electric field, where the electric field is something that points away from positive charges and towards negative charges, and it's something that a single charge does to the space around it. It sets up this thing called the electric field, and again, for point charges, it's equal to this equation here. The force and the electric field are related in that for a given electric field, if we place some charge Q in it, it will experience a force according to this relationship. Looking at why charges attract or repel using force and electric field is looking at this interaction from a vector perspective. We can also look at that same observation that opposite charges attract and like charges repel from an energy or scalar perspective. So from the perspective of energy, we would say that in a given distribution or arrangement of charge, there's some potential energy associated with that. And because there's some potential energy there, the charges are then able to move according to our observation. Just like with the electric field, we can go one step further and introduce the idea of electric potential, and that the electric potential is a scalar field created by a charge that exists at every point in space. It's the scalar equivalent to our electric field, which is a vector. We can relate electric potential energy and electric potential according to an equation that looks very similar to the one that we use to relate force and electric field, in that for a given electric potential that's set up, if we place a charge Q in that electric potential, it will have some potential energy associated with that arrangement of charge according to this equation. Lastly, we can relate this vector perspective and scalar perspective of why charges attract or repel using the gradient, in that the electric force is equal to the negative gradient of the potential energy, and similarly, the electric field is equal to the negative gradient of electric potential.